I am Harikrishna. I am from first year ECE department. I am telling about radio waves and microwaves in communication. Waves. Waves come in two kinds, longitudinal and transverse. Transverse waves are like those on water, with the surface going up and down. And longitudinal waves are like of those of sound, consisting of alternating compressions and rarefactions in a medium. Types of waves: radio waves, and second one microwaves, infrared waves, visible light, and also ultraviolet light, X-rays, gamma rays. Radio waves. Radio waves are a type of electromagnetic radiation with the longest wavelengths in the electromagnetic spectrum, typically with frequency of 300 Hz and below. At a 300 GHz, the corresponding wavelength is 1 mm. At 30 Hz, the corresponding wavelength is 10,000 km. Radio waves are a type of electromagnetic radiation best known for their use in communication technologies such as television, mobile phones, and radios. Microwaves. Microwave is a form of electromagnetic radiation with wavelengths ranging from about 1 meter to 1 millimeter, corresponding to frequencies between 300 MHz and 300 GHz respectively. Different sources define different frequencies ranges as microwaves. The above board definitions includes both UHF and EHF bands. Microwaves have a range of applications including communication, radar, and perhaps best known by most people, cooking. The microwave radiation is commonly referred to as microwaves. They fall between the infrared radiation and radio waves in the electromagnetic spectrum. Differences between radio waves and microwave. Direction. In radio wave, these are omnidirectional in nature. In microwave, these are unidirectional in nature. Penetration. At low frequency, they can penetrate through solid object and wall, but high frequency they bounce off the obstructed. In microwave, T low frequency, they can penetrate through solid object and walls. At high frequency, they cannot frequency in radio wave 3 kHz to 1 GHz. In microwave 1 GHz to 300 GHz. Wavelength range in radio wave greater than zero point 0.1 m. In microwave lies between zero point 0.1 to 1 mm. Communication in radio wave, these are used in long distance communication, and also in microwave also these are used in long distance communication. Applications in radio wave, AM, FM, and cellular systems. In microwave, radar system is aircraft navigation and microwave oven. Properties in radio wave has a low frequency and low energy. In microwave contain high frequency and high energy. Why are radio waves and microwaves are used in communication? Radio waves are transmitted easily through air. They do not cause damage if absorbed by the human body, and they can be reflected to change their direction. These properties make them ideal for communications. High frequency microwaves have frequencies which are easily absorbed by molecules in food. The internal energy of molecules increases when they absorb microwaves, which causes heating. Microwaves pass easily through the atmosphere, so they can pass between stations on Earth and satellites in orbit. Radio waves and microwaves are very important to us for communication. We can create radio and microwaves, and they are also produced by the sun and many other natural sources. Wireless communication and transmitting and receiving, broadcasting, and microwave oven, diffraction, ionosphere, signal and noise. And these are Role of microwaves and radio waves in communication. A microwave link is a communication system that uses a beam of radio waves in the microwave frequency range to transmit video, audio, or data between two locations, which can be from just a few feet or meters to several miles or kilometers apart. Modern microwaves links can carry up to 400 Mbps in a 56 MHz channel using 256 QAM modulation and IP header compression techniques. Operating distance for microwave links are determined by antenna size, gain, frequency band, and link capacity. The ability of clear line of sight is crucial for microwave links for which the Earth's curvature has to be allowed. The basic principle is simple. At one end, a transmitter encodes or modulates messages by varying the amplitude or frequency of the wave, a bit like Morse code. At the other, a receiver tuned to the same wavelength picks up the signal and decodes it back to the desired from sounds, image, data, etc. All wireless communication systems, from the home remote control up to the satellite, are based on the principle even through increasingly complex technologies are of course used to encode these electromagnetic signals, improve their quality, increases the amount of information or make transmission secure. And thank you.